Hello, in this video we will talk about a uninterrupted power supply, but this is for short duration because we're using a supercapacitor instead of using a battery. So the application is for a chicken coop. So the chicken coop has a power supply plugged into the wall that is 12.5 volts and 7.5 amp to power three components. The first one is the web camera. The second one is a thermostatic control exhaust fan. And the last one is a coop door opener, automatically a coop door opener. And the time is programmed to open in the morning and close at night. So this is what the chicken coop look like. This is the web camera, and on the lower left hand corner you can see the door that's automatically controlled, open in the morning and close at night. And the problem is occasionally we have a AC power interrupt from the power company, and it will reset the timer or the clock in the door opener to default value. So it completely messed up the timing for the door to open and close. So what I need to do is to have a short duration uninterrupted power supply, UPS, and the supercapacitor is 22 farad, pretty big capacitor, and it has a component for ideal diode, and the ideal diode has basically no losses. And then we also have a resistor for charging, because the supercapacitor is like a short circuit when it is completely discharged. So in order to protect the power supply and the inrush current, I put in a resistor to charge the capacitor. And when the power does go off, the capacitor will discharge through the ideal diode to minimize the losses. And so these are the low, and physically this is what it will look like. This is the supercapacitor, and this is the ideal diode right here, the ideal diode, and the resistor is basically a 12 volt light bulb. So first of all, let me charge the capacitor first. The capacitor has been partially discharged. So let's turn on the power supply on my bench. This is my bench power supply. And the power supply is on standby. It's still off. This is still set off. And we plug in the power supply to activate it. So we plug it in, and the supercap is at about 7.5 volt. It should be 12.5 fully charged, but it's been partially discharged. So first thing I want to do is to charge up the supercap. So this is the supercap, and I'm going to turn on charging. So turn on charging. Now the charge voltage is about 12.5 volt. And as you can see, the light bulb is coming on because electricity is flowing through the resistor. In this case, it's the light bulb, and charging the capacitors. And to simulate the chicken coop low, I have a 3-watt light bulbs here. Let me turn it on. Okay, so the light bulbs is on, and now the power supply is providing power to the light bulb and also charging the supercapacitors. So this is charging and providing power to the coop. And if we take a look at the time constant of charging, you have 30 ohm and 22 farad. So one time constant is 30 times 22, which is 660 seconds. So in order to fully charge it from completely depleted supercap, it will take 5 time constants roughly, so it's about an hour to fully charge it. But we don't have an hour in this video, so I'm going to shorten the charge time. So the next step is I will simulate a power interrupt. Just turn off the charging power supply and see what happens. So I'm turning off the power supply. So the simulate interrupt. As you can see, now the low is supported by the supercap and not by the power supply. Okay, and as you can see, the voltage of the supercap is dropping from 8.7 to 8.65 to 8.57. So this supercap is discharging and providing power to the chicken coop. And if you look at realistically, this is the equation for the time, how much would the supercap provide power to the coop, like in the middle of the night, in case there is a power goes out for a while, come back on. And the equation is the capacitor multiplied by the voltage change. So assuming you start out at 12.5 and down to about 10.1, so the voltage change is 2.4 divided by 0.44, and 0.44 is the overhead of the system typically, and it will last about 120 seconds or 2 minutes. So this is what the circuit looked like, and let me turn back on charging and see what happened. And now the voltage of the supercap is down to 7.8. Let's turn back on charging. Okay, now charging is turning back on, and the low, and now charging turning back on. You can see the light bulb coming back on, and when the capacitor is approaching full, the light bulb should be very dim or go off completely. So this is the short duration UPS using supercap. Thank you for watching. Have a good day.